Welcome class 6. Now today in mathematics we will study a new topic in geometry, geometrical figures that we are learning. In that we learn about quadrilaterals. Quadrilateral, the first word, it consists of two words, quadra and laterals. Quadra means 4, laterals means lines. In this case, straight lines. So you can see I have drawn here 3 figures. All of them have 4 sides. See, this is we are familiar with. This is called rectangle, but this also has 4 sides. This is square. This also has 4 sides. This is neither a rectangle neither a square. It is somewhat like a shape. We call it as a trapezium. That's also coming under the same category of quadrilaterals. Quadrilaterals are those geometrical plane figures consisting of 4 sides, and these 4 sides, they are not straight. All the 4 sides are not in one straight line. They are all in 4 different straight lines. See, from P till Q, these are the points I have drawn. From P till Q is one straight line. From Q till R is another straight line, from R till S is another straight line, and from P to S is another straight line. So there are 4 straight lines, and the point where any 2 straight lines meet, that is called the vertex. So P is a vertex here, where this side and this side, they meet each other. Similarly, Q is a point, or we say vertex, where this side and this side, they come and meet here. This side and this side will meet at Q. Similarly, this side and this side will meet at R. So R is the vertex, and this side and this side meet at S. So S is another vertex. So you will observe that we have angles also. This is one angle. Is angle 1. This is another angle. There is another angle, and here is another angle. So in a quadrilateral, like a triangle, we used to have 3 sides, 3 vertices, and 3 angles. In quadrilateral, everything is 4 vertices, 4 angles, and 4 sides. Which are the 4 sides here? PQ is one side. It's a line segment, okay? So PQ, then you have QR, then you have SR, and then you have PS. I'm talking about this particular quadrilateral. So 4 sides are there, 4 side segments, line segments, 4 angles, angle 1, angle 2, angle 3, and angle 4, and what else? 4 vertices. This is vertex P, this is vertex Q, this is vertex R, this is vertex S. So this is a quadrilateral. Alright. Now in this quadrilateral, there are few things that we need to know. As we know, these are the sides. Let me give names here. Say this is side 1. Let's erase this for now. This is side 2. This is side 3, and this is side 4. We have named the sides here, okay? Side 1 is PQ. Let me write in bracket. Side 2 name is QR. Side 3, let us name it as what? RS. And side 4 is PS. Alright. Few things, the terms that we need to know. Let's follow your book. In your book, you have it on page number 241. Sides, angles, and diagonals. I have already mentioned sides. I have already mentioned about angles. Now let us see what are diagonals. See, diagonal number 1. Diagonals are actually those lines which connect opposite vertices. Opposite vertices. See, opposite vertex of P is R. Opposite means they are not connected to the same side. Like PS is one side, no? So in PS we have one vertex S, one vertex P. They are in the same side. But I am talking about not in the same side. So this is P, this is R. R is opposite of P. Okay, R vertex is opposite of P vertex. When you connect a line between them, then this line is called diagonal. Okay. Diagonal 1. That's the name. Why diagonal 1? Because there is one more diagonal between these two opposite vertices, Q and S. See, Q and S are not in the same side. Remember which is side? This is side. Q and R is side. So in that R is one vertex, Q is one vertex located in the same side. But I am talking about opposite vertex, not on the same side. So like that, S and Q are the opposite vertices. If you draw a line connecting them, that will be another diagonal. So here it is. I have connected the opposite vertex Q and S. There is straight line connecting these two vertices is the second diagonal. And this straight line connecting these two vertices P and R is the first diagonal. Okay, I hope you know what is diagonal now. So, in a quadrilateral, there are 4 sides. I have mentioned the 4 sides. 4 vertices. Vertices, singular is vertex. What is vertex? Where any 2 sides meet each other. So, in P vertex, we have PQ and PS meeting each other. Similarly, Q you have this two, R you have this and this side, and in S you have this one and this side meeting. So 4 vertices, 4 sides, and what else? 4 angles. Okay, angle 1, angle 2, you have angle 3, and this angle is angle 4. And there are 2 diagonals also. Okay, 2 diagonals. Diagonals are the straight lines formed by joining opposite vertices. This and this opposite vertices, and this opposite vertices. Okay. Next topic in the same quadrilateral we will discuss is adjacent sides and opposite sides. Now coming to your book. If you have your books with you, you can open page 241. Page 241. There you have about adjacent sides. I am reading, okay? 2 sides of a quadrilateral are said to be adjacent sides when do we call 2 sides to be adjacent? Okay, for adjacent we need 2 sides. When are these 2 sides adjacent? If they have one common vertex. Vertex is also called as end point. So, how many vertices we have? We have 4, right? So, you see over here, this side PS and this side PQ, they have one end point, one vertex. So, these 2 sides are adjacent. So, which 2 sides are adjacent? PQ and PS. Similarly, PQ and QR, PQ and QR, they also have one end point, one common vertex. So, PQ and QR, PQ and QR are also adjacent. Next, QR and RS, these also have one common vertex, one common endpoint, R. So, QR and RS are also adjacent sides. Similarly, PS that is S. So even we can say PS and RS. They are also adjacent. So I hope you understand which are the adjacent sides. Adjacent in side by side. Okay. These and this have one common vertex. So this side, that is RS, and this side QR and RS, they are adjacent. Similarly, you have other three pairs of adjacent sides. So this was about adjacent. Now let us see which are opposite sides. Okay, adjacent we have discussed. Now we will discuss which are opposite sides. Very easy to understand opposite sides. These two sides, that is RS and PQ, they are opposite to each other. Why? Because they have their points, endpoints are not in one line. Let us read in your book what it says about opposite side. Two sides of a quadrilateral are opposite sides if they are not adjacent sides. Okay, we know this side and this side are adjacent, but this side and this side are not adjacent, no? So they are called opposite sides. So you have SR and PQ. They are opposite sides. Similarly, PS and QR, they are also not adjacent to each other. So PS and QR, they are not adjacent, so they are what? They are opposite sides. So I hope adjacent sides and opposite sides, the concept is clear to all of us. Okay, once again, adjacent sides are those sides which are having one common endpoint or one vertex. So in Q vertex we have PQ and QR, they are adjacent. In R vertex we have SR and QR. So SR and QR sides are adjacent. In S vertex we have this side and this side. This side is PS and this is SR, they are adjacent. Similarly in P vertex we have PQ and PS. They connect each other, so they are adjacent. Opposite sides are those sides which are not adjacent to each other. So which are the opposite sides here? SR and PQ. So which is SR? This side is SR and this side is PQ. So this and this sides, or in other words, side 1 and side 3 are opposite, and side 2 and side 4 are opposite to each other. So here it is. You can pause this video and you can actually note it down for your reference. Okay, next is quadrilateral region. Which region or area comes in the quadrilateral region? The space that is inside, the space which is inside the boundary, the four boundaries are there, the space which is inside. This space I am talking about, along with the borders. Okay, which are the borders here? The four sides are the borders. The four sides or the four border lines along with the area that is inside the borders is called the quadrilateral region. Okay. Similarly, we have triangular region also. Triangular region is what? The three sides of the triangle along with the boundary that is inside the three sides is known as the triangular region. Similarly, quadrilateral region also is the four boundaries or the four sides and the area which is enclosed inside the four sides is called the quadrilateral region. Okay, here we come to exercise 18D. Let us discuss the first question, fill in the blanks. First few questions are easy. A quadrilateral has how many sides? We all know 4 sides. So let's write 4. And how many vertices? 4 vertices. Vertices are the points where any two sides connect. Remember? Coming to question 2. A quadrilateral has how many angles? 4 angles. And how many diagonals? You know, diagonals are the opposite vertices when you connect them with a line. So how many? You have 2 diagonals. Next. third number. A diagonal of a quadrilateral is a line segment that joins two which vertices? Remember just now I said diagonal means two opposite vertices are connected. So we will write it opposite. Now here. Now there are two categories of quadrilaterals: convex quadrilateral and concave quadrilateral. I have drawn over here a concave quadrilateral, and the previous one that I have drawn, remember this one? This is a convex quadrilateral. In convex quadrilateral, the angles are all less than 180 degrees. See, each angle is less than 180 degrees. But, sorry. In convex quadrilateral, each angle is less than 180 degrees. But here in concave, see this particular angle which is inside the quadrilateral, this angle is more than 180 degrees. See, 180 degrees is this. This is 180 degrees. Right? But if you have like this, see this is one ray. Suppose the other ray it goes beyond 180 degrees. See this now? Is it not more than 180 degrees? So this case is with that. This is one ray, this is one ray, this is the point, vertex. This is the angle. It goes more than 180 degrees, isn't it? So this is concave. This is concave, this is convex. In convex, all the interior angles are less than 180 degrees, whereas in concave, one of the angle is more than 180 degrees. Keep that in mind. So, there is answer to the question then. In a convex quadrilateral, the measure of each angle of a convex quadrilateral is less than 180 degrees. Okay, is less than 180 degrees. Okay, the fifth question. Two sides of a quadrilateral, if they are not adjacent to each other, then what it is? You can go back if you don't know. Go back, rewind this video and see that section where I was discussing opposite and adjacent. If they are not adjacent, then they have to be opposite sides. Okay, if they are not adjacent, then they are opposite sides. Okay, coming to the second question. Here is the figures for the second question. Let's read. Take a point O inside the given quadrilateral. This is a quadrilateral. They are asking take a point inside the quadrilateral. So here is the point O. Okay. Join the point O. The name of this point is O. Let's give name. Join this point with each of the vertices. With this one, okay, from O till this one, from O till this one, from O till this one, and from O till this one. All the four vertices you connect with O. Let's do that. So this is one connection. This is another connection. Here is another connection. And here is another. Okay, from this point O, we have connected to all the four vertices. Now what they are asking, into what figures will the quadrilateral be divided? This quadrilateral has now been divided into four figures. What What are these four figures? This is one triangle, isn't it? Doesn't it look like a triangle? See, this is one triangle. This is another triangle. This is another triangle. And here is another. So this figure you will write is divided into four triangles. There are four triangles here. And we also have to name. They are asking, name the figures. So what are the triangles? The figures are triangles actually. So what are the triangles names? Let us name them. Triangle number 1. What do you name it? Triangle ODC. Similarly, triangle 2 is OCB. Triangle OCT. Triangle 3 name can be given as triangle OAB. And triangle number 4, the name can be given as OAB. Triangle OAB. Okay, this is the answer of question number 2. Question number 3, the problem figure is this, and in that we have 4 questions asked. First question they have asked is, how many pairs? Pairs means in Hindi we say joda. In one pair there are 2 elements. How many pairs of adjacent sides are there? Remember adjacent sides? With one vertex, 2 sides which are connected, they are called adjacent sides. So like that, how many pairs we have? For B, we have 1 pair. For A, we have 1 pair. For D, we have 1 pair of sides. And for C, 1 pair of sides. So in total, how many? 4 pairs of adjacent sides. And we have to name them also. So let us name them, starting with the A. Okay, with A vertex, which are the adjacent sides. AD and AB. This is 1 pair of adjacent sides. Next, coming to vertex B. With vertex B, which are the adjacent sides? BA and BC. BA and AB are same, okay? So I'll write AB only. This is 1 pair. So we have 2, another 2 pairs. Okay, now coming to vertex C. With vertex C, which are the adjacent sides? You have CD and BC. And the last one, last pair will be, the last pair will be with vertex B. With vertex B, which are the adjacent sides? You can say AD and CD. So we have 1, 2, 3, 4 pairs of adjacent sides. Next question, what does it say? How many pairs of opposite sides? Okay, we know opposite sides are which sides? Which are not adjacent. So we have these two opposite sides AB and CD. So we have in total two pairs. Two pairs. One is, I already said, AB and CD. Another opposite pair is AB and BC. So we will write AB and CD. Another pair is AD and BC. These are the two pairs of opposite sides. Third question. How many pairs of adjacent angles? Okay, adjacent angles. First let us name the angles. This is angle 1, this is angle 2, angle 3 and angle 4. Keep in mind opposite vertices. So angles which are in the opposite vertices, like A and C, these are two vertices which are opposite to each other. So angle 1 and angle 3 are opposite angles. Similarly, vertex B and vertex D, they are opposite vertices. So angle 2 and angle 4 are opposite angles. So question is, how many pairs of adjacent angles are there? And the next one is opposite angles are there. So just now I said about opposite angles. So which are adjacent angles? See, which are not opposite, they are called adjacent. 1 and 3 are opposite, but 1 and 2 are not opposite. No? In adjacent angle, see, this is one angle, this is another angle. Now what if they are connected? What if they are connected? See, this is one angle, this is another angle. This is for this particular angle, this and this is the side. For this particular angle, this and this is the side, but you can see one side is common to both the angles. Can you see that? One side is common to this angle also and this angle also. So those angles whose one side is common to both the angles, they are called adjacent angles. So in angle 1 and in angle 2, side AB is common. So angle 1 and angle 2 are adjacent angles. Similarly, angle 2 and angle 3. See, for angle 3, this is the angle, this side, and for angle 2, this is the angle. Again, this side are common to each other. So one side is common, so angle 2 and angle 3 are adjacent angles. Similarly, angle 3 and angle 4 are adjacent angles. Angle 4 and angle 1 are adjacent angles. So how many pairs of adjacent angles we have? 4. So let us write which are those angles. I said angle 1 and angle 2 are adjacent, right? So what is the full name of angle 1? Angle BAD. And this angle name is BAD. What is the name of this angle? ABC. Angle ABC. These two are adjacent. Okay, next I said angle 2 and angle 3 are also adjacent. What is the full name of angle 2? Angle 2 full name is ABC. Angle ABC. And what is the full name of angle 3? BCD. Angle BCD. Then I said angle 3 and angle 4 are also adjacent. Okay. What is the full name of angle 3? We have angle full name. Angle 3's full name is angle BCD. And what is the full name So these are the four pairs of adjacent angles. Now four pairs of opposite angles. Sorry, not four. Two pairs of opposite angles. Okay, what are opposite angles I said? Just know which are not adjacent, they are opposite. And opposite angles are formed with opposite vertices. C and A are opposite vertices. So angle 3 and angle 1 are opposite angles. So with this one, what is the full name of this angle? B is D, angle BAD. And with the full name of angle 3, BCD, angle BCD. So this is one pair of opposite angle, which is the other. See, vertex B and vertex D, they are opposite vertices. So angles with vertex B and angle with vertex D. That is angle 2 and angle 4, they are opposite. They are opposite angles. So what is the full name of angle B? Angle ABC. And what's the full name of angle D? Angle 4 with vertex D, angle ABC. So two pairs of opposite angles are there in this figure. Okay, now this question number 4 is answer true or false, and I have added one bit. That is, if any statement is false, then you correct the false. It will be for your own good. You will know what the exact answer should be for the false sentences. First question is, no two vertices of a quadrilateral lie on the same plane. If you had attended this class, in the beginning only I had said, in a quadrilateral, all the 4 points are on the 4 different lines. No 2 points, no 3 points will be in one line. This is in the definition of quadrilateral also. You can go and see on page number 241, there it says. Okay, there are 2 points, 2 or 3 points which talk about quadrilateral. In that it is said, no 3 points in a quadrilateral will be in one line. You see over here, this is a quadrilateral. Okay, 1, 2, 3, 4 sides are there. 2 points will be in one straight line. But this and this, there are 3 points. Are they in one straight line? This is in one straight line, this is in another straight line. So, it will not be 2 vertices, it will be 3 vertices. No 3 vertices of a quadrilateral lie on the same plane. Okay, the second question is, all points on a quadrilateral belong to its interior. That is true. Okay, that is true. Third one, a line joining any 2 points on a concave quadrilateral. I have drawn for you a concave quadrilateral. Okay, so the line joining any 2 points. How many points are there? Points or vertices in a quadrilateral? There are 4, right? So, any 2 points in a concave quadrilateral, if you join, then that line will be inside the quadrilateral. Is it true? Let us see. Okay, you can see over here, this point and this point. If I join it with a line, this line, it is inside. This space that I have drawn over here, this space is inside the quadrilateral. So this line is inside the quadrilateral. But the other points, if I join this point and this point, then it is on the boundary. It is not inside the quadrilateral. If I join these 2 points, then the line that I get is on the boundary. Similarly, this and this point, if I join them, then the line that I get is on the boundary. Similarly, this and this point, it is in the boundary. Only one set of points, that is this point and this point, if I join them, then the line that I get is inside the concave quadrilateral. Not all. So this is false. So what will be the true statement? The line joining any 2 points in a concave quadrilateral does not always lie inside the quadrilateral. That will be the correct sentence. Okay. So this is the correct sentence. Okay. For part 3, a line joining any two points in a concave quadrilateral does not always lie inside the quadrilateral. Okay, there is a slight correction in the numbering. Okay, this question 4 part 3 we had actually missed. Let us discuss that. All points on a quadrilateral belong to its interior. No, not only interior, we had studied that all points in a quadrilateral belongs to the borderline, that is the four sides, as well as the interior. Okay, that is called the quadrilateral region. Remember, like triangular region, we have quadrilateral region also. In that, all the points belong to the borderline as well as on the inside also. Fourth one we had just discussed earlier. I had mentioned it as question number 3. It is actually question number 4. So it's the same thing I have written all over again. Fifth one, a quadrilateral has only 2 points of adjacent sides. No. 2 pairs of adjacent sides is wrong. 2 pairs of opposite sides. Quadrilateral has 2 pairs of opposite sides, not adjacent. Adjacent there are 4 pairs, remember? Okay. So 2 pairs of opposite sides, not adjacent sides. So these are the true false. I have corrected the false ones so that you will know what is the correct answer.